All right, thank you, Svante, and welcome everybody to the first Software Spotlight. We have a series of software spotlights over the course of the summit. The first one will be about data and AI and how we are bringing AI into your workflows. In this session, we want to do two things. First, we want to show you what we have done in terms of Gen AI developments, which integrations we have built for Knime Analytics platform. And then the second piece will be about all of these quality of life features, the enhancements to modern UI, etc. pp, which are super important to actually build the workflows in the first place. I'm really happy to have first Adrian Nembach on stage, our team lead AI, and afterwards Carsten Haubold. Adrian will show us with a really nice, interesting use case how we can actually leverage AI within your workflows, and then Carsten will talk about the quality of life features a bit more detail. Thank you, Adrian.
Thank you very much, Christian. I just need to quickly plug this in, and then we are good to go. Perfect. Can I have this? All right. So in terms of use case, actually, can you show me this slide? We wanted to give a high-level overview first. Well, we thought we will try something where we have different kinds of data, and that might be a little bit relatable to at least some of us. So we thought, let's predict flat prices, in this case in Zurich, because it turns out Zurich has a really nice data catalog that we can find the data to kind of do the model, the prediction part with. But the tricky part always is, it's really nice to think about what kind of model are we going to use, like how do we do all of the machine learning bits and pieces that are kind of super interesting, but then actually finding the data to do that can be tricky. And in this case, the data catalog has more than 700 data sets, and we didn't want to go through all of them by hand to figure out which ones are useful, because it's just super time consuming and a little bit of a, dare I say, boring task. But it's something where we could maybe use Gen AI, and that's the first part of the demo. So there I will try to show you how you can use Gen AI to find the data inside of your data catalog that you need to do your actual predictive task. And then I hand over to Carsten to really show how we do the prediction and show a lot of the Knime features along the way. And with that, we will just switch to the demo. All right. So this workflow may look a little bit daunting, but I'll just start here kind of at the big picture. What we will do is we will connect to different inputs. One is the Gen AI providers that we're going to use. Another one is going to be the user input, in this case just a description of the task. We want to predict flat prices by urban quarters. And then we will also connect to the data catalog that we want to search through. In the next step, I will do what I would probably also do by hand. I'll search for candidates using a search mechanism, essentially. But then I need to screen if those candidates actually are fit for what we're trying to do. And in the end, here in the filter by planning step, I will actually kind of look at all the different data sets together and figure out which ones I really need and which ones may be redundant, for example. And once I'm done with that, I can hand over the data to my colleague. In this case, I download them, but I could also write them into a database or the cloud somewhere where my colleague can access them. All right, now let's dive into the details a little bit more. All right, so let's go to the connect part. In this case, I connected to OpenAI. I guess everybody knows those guys by now. I also connected to DeepSeek. They have been quite a bit in the news recently, and we were rather quick to add connectors for that, where we can connect to the DeepSeek reasoner model. This is also often referred to as R1, and we will use that for our first step in our workflow. But before we go to that, let me quickly show you that these are not the only connectors we have. We have a whole suite of connectors. We can also connect to Azure OpenAI. We can connect to Databricks if you have models hosted in your Databricks workspace. DeepSeek I already showed. With GPT-4All, we can actually run models locally on our laptop, for example. And with Hugging Face, we can access all kinds of open source models that are shared on Hugging Face. We also have the Knime Gen AI connector, and there is more to come as well very soon. With that, let's go quickly to the user input. I already mentioned that this was just going to be a task description. In this case, it's a string input widget where we just say, okay, identify data sets which could help me with my task, essentially. All right, and then we also connect to the data catalog. And here we will see we have actually roughly 700 data sets, so we don't want to go through those by hand. Now let's see how we can do that with GenAI. So first of all, what you would probably do is search for candidates, right? And there I built a little vector store, which allows me to search by candidates using just natural language. But of course, if you think about how you would tackle this by hand, you would not really say, I search exactly with the description of the task that I want to do. I would think first, okay, what kind of data would be useful? And this thinking bit, we kind of outsource to the reasoning model in this case from DeepSeek, where I just ask it, hey, please devise a plan and give me search queries that could be useful to solve this particular task. I'm using a new feature in 5.4 here, the system message for the LLM prompter, which is quite useful because now you can define what the model should do right inside of the prompter. You don't need an extra node to do that. Now that after we run our model, we can extract the queries and we end up with 10 search queries that you can inspect here. And then we use those search queries to run them against our vector store, and we get a lot of results. Some of them will be duplicate, right? Because we have kind of search queries that might end up with similar results, and we can remove those duplicates easily, and we end up with 151 data sets. From 700 to 151, it's already a great reduction, but of course, that's still too many to hand that over. So let's go to the next step where we screen for task fit. In this case, setting up the prompt, as Michael said, the prompting is also a bit of a challenge, was not that easy. So we used a variable expression node to build a bit more of a complicated one. And here I would just like to highlight our new expression nodes that have really nice features, including the ability to define multiple expressions in the same node and reference them in other expressions within the context of this node, where we can set up different parts of our prompts and mix and match them together easily. And here we really just tell it, hey, please give us a rating, how well the data set fits our task. After we run this, we can extract both the rating and a reasoning. So here we see we have a lot of ratings of 1, so 1 means not useful at all. Oops. And we also have some 4 ratings, and if we look at the reasoning, here we have another really nice new feature. We can double-click on the cell, and it pops out this cell view, which is much easier to read, especially for if you have multi-line data or maybe JSON files or JSON data as well. But there's even more renderers for this, and I think you will see some with what Carsten is showing us later on. All right, in the next step, we just use the rating to filter out anything that we find not super interesting. So now we are at 54 data sets, another great reduction, but I was still not really happy with it and thought, well, maybe some of those still, if you really look closely at the details of the data set, they still are somewhat redundant, or maybe you find out, the quality is lacking. So in the next step, I thought, okay, I can just ask the model to do that, but it turns out it was not that simple, and I had to trick the model in actually doing what I wanted. And the way I did it is that I asked the model, hey, come up with a plan, but please reference the data sets that you would use to actually fulfill this task. And then we can just look which ones it referenced, and those are the data sets that I will hand over to my colleague, at least in the first iteration, so that he has a good starting point. And here we end up with only 16 data sets, which is way more manageable than what we started out, which was 700. And the rest of it is really just writing out the data or handing it over. And the thing here to kind of tie this back to what Michael talked about earlier, in a sense, this is a tool, right? So you give it an instruction, find the data, and it gives you the data back. It uses, it's data aware, right? It's working with data, and it's somewhat intelligent under the hood. So this does check the boxes for this kind of data aware tool and intelligent tool. And whether the agent is a human agent, like my colleague Carsten, or an AI agent, does that really matter? That's something that we will see in the future, I guess. But now I'll hand over back to Christian.
Thank you, thank you, thank you. Thank you very much, Adrian. So in a nutshell, you basically had a ton of data in a data catalog, and you used large language models to actually select the relevant ones out for your colleague that he doesn't need to deal with 700, right?
Yeah, absolutely. I mean, the thing is, it's generative AI, but you can actually also use it to reduce the amount of data quite nicely.
Okay, and you also volunteered to talk to everybody here about prompt engineering and nitty-gritty details, how to optimize your prompts over here tonight, right?
Yeah, if you can find me, but that sounds like a daunting task.
Perfect. Thank you again, Adrian and Carsten. Okay, Carsten, walk us through the second part of the use case and what you're going to do with the datasets, please.
Yeah, sure. Thank you. So I'll switch right back to the demo. Perfect. And now Adrian has provided me already with a lot of data sets that, or well, a manageable amount of data sets, thanks to AI, that I could use for the flat price prediction in Zurich, which is our task. And what I'm going to do with this now is build or well, I already prepared this for you, is a very common pipeline of data analysis. We're loading and preparing some data, then we're training a model, we're predicting these prices, and at the end we can evaluate how well our prediction works and then use that later on. And I bet you've seen this kind of setup a million times already, so I'm not going to go a lot into detail, but what I'm going to do is look at the features that we've added in Knime in the last time. And so you're already seeing, well, we work with Zurich, so it's geospatial data, and next to that, or in that data catalog, there's actually information about all the suburbs, all the quarters in Zurich. And one thing we have is this geospatial integration, and there we already see in the table down here, Adrian was already having a cliffhanger for me to show this, that we can also double-click on geospatial data here, and you get highlights of all the different quarters. If I just cycle through them, you'll see different parts of Zurich, and it fetches the data behind the scenes, and obviously you can look at all of them. These are all the quarters that we will predict the prices for. What I want to highlight here is that we're now embedding the node dialog that you use for configuration. Here the question is, which information are going to be shown in the tooltip, or if I click one of these quarters. This is the node configuration, so we have embedded this in the UI. We have the view embedded at the bottom. We have the node repository on the side that Adrian already showed, so you have everything at your fingertips all the time, which is really nice. And there's not just the two nodes for geospatial analysis that I showed here, but there's many more, and you can also access them by using these quick node insertions. So if I use for geo, I'll get all kinds of nodes that work with geospatial data, and I don't know whether you've already seen this, whether we've mentioned this in previous demos, but it has been a game changer for a few people now, that you can also do this backwards. Basically, you can also say, I need a geo reader to get the data that I want to have in my view. All right, but now, enough for geospatial data for now. Let's look at the data sets briefly that we loaded that were suggested by AI. So basically, I have a bunch of data sets. These are the ones that Adrian provided me with. If I look at one of them, it's basically a CSV reader with the file he just downloaded, and then plus some data preparation, getting the column names in shape, and turning things around if they're not expected to, in the way I need them for a prediction later on. And now we can do this for all the data sets, join them. Nice, and that's standard data wrangling. Now, reading CSV files is not the most exciting thing we can do, right? So there's many more data sources that you can access with Knime. I mean, you probably looked at the I/O category at some point, and there's many things that we can read from. We have the database integration, so where you can connect to all kinds of databases like SQLite, Postgres, Oracle, and so on and so on. We've added two things recently that I want to bring your attention to here a little bit. One is the Databricks SQL Warehouse connector, which is pretty cool because you can you connect to your SQL Warehouse and you can use all the normal database nodes in Knime to work with that later on. And when you work with a provider like Databricks, or all kinds of databases, usually you need to sign in first, right? You need some kind of credentials to connect to that. And You can either, whenever you run the workflow, have your user enter the credentials, or when you store the credentials somehow. But what we can do now is when you connect to a hub, you can, in your hub team or in your personal account in the hub, you enter credentials, and then you can use the secrets retriever here, which fetches the credentials that are available. Now it's for me because I'm logged in, and you see in my team there were two tokens, two credentials for OpenAI and DeepSeek. These were actually used by Adrian. He hid that somewhere in the nodes, and I'm using the Databricks credential now, which makes this super convenient. So whenever I open the workflow, I'm signed into the hub, I can just run this. And another thing that we can do now where we can connect to is Tableau. I know that a lot of users have been waiting for this, so now you can finally read your hyperfiles and get the data from there when you build your Knime workflows, which is super nice. And so we're adding more and more of these features where you can read data from data sources and data sinks. There's one more node here that I briefly want to touch upon. That is the date and time pod extractor. This is one node of a large collection of nodes. When we look for a date, we have time series. We have lots of nodes that allow you to work with date and times. We are currently, or we have been working on bringing these to the modern user interface, making them easier to use, more nice to look at. And so this can be integrated in the side panel as well. And actually, we're also adding date and time support in the expression node. So all of this will be coming in the next release. And while we're modernizing all of these nodes, even though I'm here doing the non-AI part of the talk, we're actually behind the scenes using AI to some extent when bringing nodes from the classic user interface to the modern user interface, and we're working on making a data app available to all the extension developers out there who are building Java nodes, and then they can bring these to the modern UI easily, so we all go this transition together. And yeah, well, with that, now I have lots of data. Combine the features, train a model, predict, and now we can briefly look at that. So for it, I have data over multiple years for all the quarters. So let's pick one. If we want to look at this, the green line here is my prediction, and it actually not too bad. So the trend is pretty nice. We can, for instance, also look at the difference of the prediction versus what the prices actually were in 2024. I excluded that year from the training data to be able to evaluate, and there we see the city center is pretty overpriced. Actually, the prediction was lower than the actual prices, but here the yellow area, the prediction was higher than what people paid for a square meter in their flats, and so maybe that's the reason, the area where we should buy, because everything points to that's nice, but not super expensive yet. And then last thing, because we're doing classical machine learning, that has the advantage, it gives us also a feature importance. So you can later on look at what makes up the prediction, which features were actually important to make up that prediction. And now this is just a simple example, but you can look through which of these these are. And here I'm curious because I know that this is sports activities. You can pick a bunch of features here and see how much influence they have. And so I get a detailed view. And for me, as a sports person, I'm not that sure whether it's nice that having sports activities around lowers the prices of the suburb. But well, anyways.
Thank you very much, Carsten, for that. So you talked about a lot of new capabilities already, but what's in the pipeline? What's cooking? What's coming next?
Sure. So if we can, go to the slides. Yeah, what's cooking? There obviously are a bunch of things in the pipeline. You already saw that we're modernizing a lot of nodes. We're bringing them to the modern UI. And what's next in the pipeline, basically, and what we started with already, is bringing all this database framework into all the nodes in the database framework into the modern UI. And there you have the SQL editors, for which we also want to add AI capabilities, so that you can, the same way as in the expression in the Python node, you can let Kai write your SQL statements, basically. We're making it easier to work with large data workflows, and something else that you see in the screenshot below is that we're adding hub functionality inside the analytics platform to make that even easier, so you don't have a context switch. When you upload a workflow, you can immediately create a version, you can start a deployment, all kinds of these things. And to get back to what Adrian was showing before, in terms of AI nodes, we're adding more capabilities to make it easy to build AI agents, also what Michael was talking about in the morning. We're always adding nodes to access the last hot LLMs, and we're working on getting multimodal models into your workflows. And I don't know whether any of you noticed, the whole demo we were showing had a browser bar on top. So the whole UI was running in the browser, and Jim will talk about that a little more in the afternoon.
Thank you, Carsten.
If you want to play around with these use cases, go download the workflows.
Thank you. Thank you, everybody, as well, because a lot of the developments you have seen on this is coming from you, feedback from you guys, from the audience here or the online community. Keep the feedback coming, keep it coming. We will do our very best to accommodate and introduce things you want into the analytics platform and the hub. Thank you very much.